Okay, so I'm going to talk about the ratio of similarity and scale factor. So we already talked about that a little bit before. We know that um, the ratio of similarity or scale factor, or in other words R, is a way of comparing items that are similar, in this case triangles, and we're talking about these linear measurements, which are perimeter in this case. So what I'm going to do is I'm going to set up a proportion 2/3 is equal to, and I'm going to put the perimeter of the small triangle on the top in the numerator because that's where the smaller number is, and I'm going to put x, which is representing the perimeter of the larger triangle, in the denominator. So cross multiplying 2x equals 12 times 3 is 36. Dividing both sides by 2, I'm getting x is equal to 18. So the perimeter of the larger triangle is 18 inches. Okay, second part of the question, one of the side lengths of the larger triangle is 6. What is the length of the corresponding side in the smaller triangle? So once again, we're talking about linear measurements, so I'm going to use R, which is 2/3, the scale factor. I'm going to set that equal to, it says one of the sides of the larger triangle, so 6 is in the denominator, x is in the numerator. Cross multiply 3x equals 12, 2 times 6, which is 12. Divide both sides by 3, I'm getting x equals 4, and we're talking about inches here. So the length of the corresponding side in the smaller triangle is 4 inches. Okay, let's take a look at some more. So another example, we have similar rectangles, and we are given their perimeters in order from smallest to largest. If the smaller rectangle has a side length with 8 feet, what is the length of the corresponding side of the larger rectangle? So I first have to figure out, I wasn't given the R value, the scale factor, so I have to figure that out. So 36, we're going to put that over 48, and we're going to simplify to get the scale factor. So that's going to be R. So when I simplify 36 over 48, looks like 12 goes into each, so divide 36 by 12, that's 3, and divide 48 by 12, and that's 4. 3/4 is my R, or my scale factor. So I'm going to use 3/4, and I'm going to set up a proportion. I'm reading here, it says the smaller rectangle has a side with length 8 feet. So smaller, 8 is going to go in the numerator, and x is going to go in the denominator because we're going to get the corresponding side of the larger rectangle. So cross multiplying 3x equals 8 times 4 is 32. So I'm dividing both sides by 3, and I'm getting, looks like 10 would be, 10 times 3 is 30, so I have 10 2/3, and these are feet. Okay, so that's the first part of the question. Then it says, what are the dimensions of both rectangles? Well, let's start with the small rectangle, and I'm going to draw myself a picture here. So I know that we have 8, and because we know what a rectangle looks like and the opposite sides are congruent, I'm going to go ahead and put 8 there. Well, 8 plus 8 is 16, and we were told the perimeter is 36, so I'm going to subtract that 16 and get 20, but 20 is not the other side, it's not the width, because it's, in this case, it's representing 2 widths. So I know those 2 widths are congruent, so I'm going to divide 20 by 2 and get 10 each. So the small rectangle has dimensions 8 feet by 10 feet. Okay, now let's take a look at the larger rectangle. So I'm going to go ahead and draw that. We just figured out that 10 2/3 was the side that corresponds to 8 in the smaller rectangle. So I'll go ahead and put that on the other side. So when I double 10 2/3, when I double 10 2/3, I'm getting 21 1/3. So I'm going to subtract 48 minus 21 1/3, which gives me 26 2/3. And remember, that's the 2 width, so I'm going to divide that by 2. And when I do that, I'm getting 13 1/3. So 13 1/3 and 10 2/3. So I'm going to write the larger dimensions. We'll start with the corresponding to the 8, so we'll start with 10 2/3 feet by the larger, which is 13 1/3 feet. And those are the dimensions of the larger rectangle. Okay, so let's take a look at this word problem here, application problem. So we are supposed to find the distance across this swamp. So we're talking about here. And notice that we do have these similar triangles. And how do I know that? Well, real quickly here, we know vertical angles are congruent. And we also know, we were told that the lengths here are here and here that I have highlighted, they're parallel. So there's my transversal, alternate interior angles. I could do that again on the other side, but I don't even need to because I already have two angles. 1, 2, 3, 1, 2, 3. So by angle similarity, these two triangles are similar. So let's set up a proportion. So I'll start with the distance I'm trying to find, AB. So we'll call that X. Now that's in the larger triangle, so now I'm going to look in the smaller triangle. The corresponding side is the side between the angles marked 2 and 3, so that's 176 is equal to, now I have to go with the 95 because that's the only other side I know in the small triangle. So small in this proportion is on the bottom in the denominator, so 95. And then I have to go to this corresponding side in the larger triangle, so between the 1 and 3 angle, 1 and 3 angle, that's 218. So I'll cross multiply and solve. So I have 95x is equal to whatever 218 times 176 is. So let me figure that out. 218 times 176, and that is 38,368. Dividing both sides by 95, I'm getting x is approximately 403.87, and these are meters. So 403.87 meters across the swamp. Okay. Next, let's take a look at a word problem here with similar figures. So we have this 10-foot tall tent. Anytime we're reading a word problem, you definitely need a picture. So I'm reading 10 feet tall. Tall I know is vertical, so I'm going to go ahead and make a vertical line and label it 10. Now, it says that it's standing beside this cardboard box, so I'll put the cardboard box there, right beside it, or close to it. And I don't know how tall that is, so I'll call that X. And both of these are casting a shadow. Well, casting a shadow means there's a sun up here, okay? And the shadow's coming down. Okay, so we have this shadow from the tent here on the bottom, the longer length, and we have the shadow in the smaller triangle from the cardboard box. Well, we know that that shadow is 6, and we know, we were told, this whole entire shadow for the tent is 12, and these are all feet. So now I have similar triangles. I have this smaller triangle, and I have the bigger triangle. If you want, pull out the smaller triangle if it helps you, and that has X and 6 as measurements. The larger triangle has 10 and 12. So we're ready to set up a proportion. So X over the corresponding side in the big triangle is 10 is equal to, back to the small, 6 over the corresponding side, whole length there of the big triangle is 12. So we can cross multiply. 12x is equal to 60. Divide each side by 12. I'm getting x is equal to 5. And that answers our question, how tall is the cardboard box? It's a 5-foot tall box. Okay, now I'd like you to try some problems similar to these in your workbook on these pages here. Good luck on those.